Good morning, all of you. Last lecture we have studied about a Gauss law in electrostatics. In today's lecture we have to study a very important concept in the electrostatics. That is, first one is a divergence of Ebar in electrostatics, and second one is we have to study curl of Ebar in electrostatics. These 2 points are very important in this topic. Many times question may be asked on that topic, that is, for divergence of a Ebar in electrostatics we have to calculate what we have, a divergence of Ebar in electrostatic. Question may be asked on that, derive the relation for divergence of Ebar in the electrostatics. This is your target. First of all, we have to study what is divergence, and after that we have to study curl of E, divergence of E and curl of E. These 2 points we have to study in this today's lecture. Now, for the calculating the divergence of electric field, divergence of a E, first of all we have to know what is electric field intensity. That is, we have to study it on the last lecture, that is electric field intensity, and we have to derive one more formula for the electric field intensity in the 12th standard. That is what we have to say, that electric field intensity is given by that is E bar is equals to what we have to say, that electric field at a distance we have to calculate this R, and that is equals to, we have to say that 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught. This is a constant factors we have to consider for the electric field intensity, and integration of, we have to consider that, say 1 upon r square into r cap into dq. What is dq here? That is considered as a charge, and this equation is, we have to consider, say, equation number 1. We have basically in the magnitude what we have to say, that E is equals to 1 upon 4 pi epsilon 0. What is the integration of dq here? That is q. That is q upon r square. This is the formula for electric field intensity. E is equals to 1 upon 4 pi epsilon 0 q upon r square. This is the formula for electric field intensity, and here we have to find what is the divergence of electric field intensity, E bar. This is your target we have. Now, for calculating the divergence we have to know that what is a current density. In 11th and 12th standard we have to study a linear density, that is charge per unit length, surface density, that is charge per unit area, and what we have to say, that is volume density, that is charge per unit volume. Here we have to consider, we have to know that a charge density rho is given by charge density rho is given by, what is the formula we have? That is charge density, let us again we have to consider rho of R is equals to charge per unit volume. What is d2 here? d2 is called as small, d2 is called as a small volume element. d2 is called as small volume element. Therefore, we have to write that dq is equals to, what you have to get, rho of r into d tau. Tau, some books we have to use a tau or dv. dv is also considered as what? This is what we have to say, that d tau. d tau is a small volume element. Symbol have is well meaning. We have to use d tau, or we have to consider, say, dv. Substitute this in equation number 1. Put in equation 1. What you have to get that? E bar of R is equals to 1 upon 4 pi epsilon naught into, we have to say that volume charge density we have to use here, that is rho, means we have to say that over a volume V, that is R cap divided by R square into, what is the value of dq here? dq is considered as what? Rho of R into rho of R into d tau. This is the value we have to consider. This is a equation number 2. Taking divergence both sides. Taking divergence, equation 2 becomes, taking divergence, equation 2 becomes, therefore divergence of, this is a symbol for divergence, that is del, divergence of E bar is equals to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught over a volume V. Then we have to take the divergence of R cap divided by R square into rho of R into d tau. But divergence of R cap upon R square is equals to 4 pi. Divergence of R cap upon R square is equals to, you have to consider, say 4 pi is the constant into delta cube of R, where delta is called as, delta is called as, delta is a Dirac delta function, where we have to say that delta is a Dirac delta function. Delta is a Dirac delta function, where delta is a Dirac delta function. Dirac delta function. This is equation we have to consider, say, 3rd. Put in equation 3. This value we have to substitute here. What you have to get that? Divergence of E bar is equals to 1 upon 4 pi epsilon naught into volume integration of, this value is what? 4 pi delta cube of R rho of R into d tau. Again we have to say that 4 pi is cancelled with what we have? 4 pi, and 4 pi is cancelled with 4 pi. Here what we have to remaining, that is 1 upon epsilon 0. Rho is the constant, and we have to say that volume integration of Dirac delta function is a unity. The volume integration of Dirac delta function is unity, but volume integration of Dirac delta function is unity. Unity means what? 1. Therefore, what you have to get that? Divergence of E bar is equals to rho is taken out. And what we have to say that? Rho of R divided by epsilon naught. And what we have to say that? Del Q bar into ditto, that is called as a unity, and this is called as a divergence of E bar is equals to rho upon epsilon 0, and this is nothing but what? This is Gauss law in differential form. In integral form, we have to take the volume integration of divergence of E bar into d tau is equals to, volume integration can be transferred to surface integration of what we have to consider, that is a E bar dot dA bar. E bar is the electric field intensity and dA bar is considered as what? The surface element, and that is equals to, we have to say that 1 upon epsilon naught into volume integration of rho of d tau. Here volume integration can be vanished with volume integration, and this is nothing but what? Rho into d tau. Rho into d tau is considered as what? That is, we have to say dq, and finally it is equals to q enclosed divided by epsilon naught, and this is the integral form of the divergence we have. I think this is a very important article, that is divergence of E bar in the electrostatics. For this article, first of all, we have to calculate the divergence of E bar. While we have to calculating the divergence of E bar, we have to know E means what? E is called as electric field intensity. We know the formula for electric field intensity. What is the formula for electric field intensity? E is equals to 1 upon 4 pi epsilon 0 Q upon R square. This is in magnitude, but here we have to use for any space volume, that is E of R is equals to 1 upon 4 pi epsilon 0 integration of 1 upon R square into R cap. R cap is called as unit vector, which is always in the direction of E bar, and dq is a charge, and the integration of dq is considered as what? Q. This is equation number 1. Now here comes charge, means what? Charge density. Charge density is denoted by rho, and rho is given by which charge density? That is volume charge density. What is volume charge density? That is a charge per unit volume, and charge per unit volume is considered as dq upon dt. And then after that we have to say that d tau is a small volume element. We have to use d tau, or it is also called as what? dV is called as a volume element, and then we have to write that here dq is equals to rho into dt. d tau. This is a equation. This can be substituted in the equation number say 1. It gets that E bar is equals to 1 upon 4 pi epsilon 0, that is volume integration of, this is R cap upon R square as it is. We have to substitute the value of dq. What is the value of dq? Rho into d tau, and it gets that this formula, equation number say 2. I think we have to, isn't it? This is very important. Now taking divergence both sides. So taking divergence, equation 2 becomes divergence of left side and divergence of right hand side. That is, divergence is nothing but the del operator. Remember, that is del of E bar is equals to 1 upon 4 pi epsilon 0 into divergence of R cap upon R square into rho of R into ditto, equation number 3. But divergence of r cap upon r square, this is a one function, and that function is called as Dirac delta function. And for that Dirac delta function, that is divergence, very important formula. This formula we have to remember. This is very important here. Divergence of r cap upon r square is equals to what? 4 pi into delta r cube. Right. Substitute in equation number 3, where del is called as Dirac delta function, and it gets that this is what we have to say, that divergence of r cap upon r square is nothing but the 4 pi into delta cube into r and rho of r into ditto. 4 pi gets cancelled. It gets that 1 upon epsilon 0 del cube rho of r into dt. But rho of r is what? Constant factor, which is taken from the out of the integration, that is rho of r divided by epsilon 0, and the remaining term is what? Delta cube into ditto, and this is called as a Dirac delta function integration. That is the volume of integration of Dirac delta function is always unity, means 1. That is integration of delta cube of r into ditto is 1. Remember, this is unity, or that is Dirac delta function volume integration is what? Unity. This is very important statement. Volume integration of Dirac delta function is unity. Volume integration of Dirac delta function is unity. Volume integration of Dirac delta function is unity. And divergence of r cap upon r square is equals to 4 pi into delta cube into r. This is very important formula. Many times question may be asked on that. For multiple choice question, what is the volume integration of, what is the divergence of r cap upon r square? Divergence of r cap upon r square, and that is what we have to say, that 4 pi into delta cube. And after that, we have to substitute this one. It gets the equation number 4. Divergence of Ebar is equals to rho of r upon epsilon 0. This is equation number, say, 4. And that equation number 4, this is called as what? A Gauss law in differential form. This is called as Gauss law in differential form. Now, in integral form, what we have to consider for the Gauss law? Means we have divergence of Ebar is equals to rho upon epsilon 0. This is a very popular form, that is called as differential form of Gauss law. After that, we have to derive one more form, and that is called as what? Integral form. And while taking integration, what we have to get, that volume integration of divergence of Ebar into ditto. We have to study it always at the last period, that is divergence of Ebar into ditto. This is volume integration, and volume integration is equals to what? Surface integration. Which theorem is used? Divergence theorem is used. And for divergence theorem, we have to use that. We know the divergence theorem is what? Surface integration of Ebar dot dA bar is equals to Q enclosed upon epsilon 0. What is Q enclosed? Q enclosed is nothing but the total charge enclosed in that surface, and that is nothing but what? We have to say that rho of dt, and rho of dt is nothing but considered as what? A total charge dq. And finally, we have to get that divergence of Ebar into ditto is equals to surface integration of Ebar dot dA bar, and that is equals to 1 upon epsilon 0 into volume integration of rho of dt, and that is equals to Q enclosed divided by epsilon 0. This is called as what? A divergence of Ebar. Question will ask on that. Write a short note on divergence of Ebar in electrostatic for 5 marks, or sometime derive the relation of Ebar in electrostatics. This is also sometimes what is the divergence of r cube upon r square is equals to 4 pi into delta cube into r. This is for multiple choice question. This is also, which of the following is the differential form of the Gauss law? Divergence of Ebar is equals to rho upon epsilon 0, or sometimes integral form of a Gauss law we have to consider. This is a divergence of Ebar into ditto is equals to surface integration of Ebar dot dA bar is equals to 1 upon epsilon 0 rho of delta u enclosed upon epsilon 0. This is called as integral form. Understand? Write down all these points, very important. Distance.